Are you ready to witness one more milestone in space travel and exploration? With its recent maiden launch, Europe's newest marvel, the Ariane 6 rocket, exceeded our expectations. With its innovative design, this spacecraft ushers in a new era of space missions while increasing payload capacity and lowering costs. Space launches epitomize humanity's quest for exploration, pushing the boundaries of science and engineering. From the historic Apollo moon missions to modern SpaceX endeavors, each launch represents a leap into the unknown, fostering innovation and uniting us in the wonder of discovering the cosmos. Like any other space launch, everyone's thrilled about the latest one, Ariane 6. But why was the launch delayed, and what makes the launch of Ariane 6 so different? Let's find out. The long-awaited Ariane 6 was finally and officially launched on the 9th of July 2024 at 3:01 p.m. EDT from Europe's spaceport in Kourou. The Ariane 6 is a next-generation launch vehicle developed by the European Space Agency and Ariane Group. The rocket is the culmination of work across 13 European states and more than 600 companies across Europe, with Ariane Space as the prime contractor. Ariane 6 was planned in the early 2010s as a replacement launch vehicle for Ariane 5, with a number of concepts and high-level designs presented and offered between 2012 and 2015. It represents a significant leap forward in terms of cost efficiency, versatility, and performance compared to its predecessor, the Ariane 5. But before we delve into the specifics, let's take a moment to understand the context and history leading up to this monumentous launch. The Ariane family of launch vehicles has a storied history, dating back to the first Ariane 1 launch in 1979. Over the decades, these rockets have been pivotal in establishing Europe as a key player in the global space industry. The Ariane 5, introduced in 1996, became renowned for its reliability and capability, launching a variety of payloads including satellites, scientific missions, and even interplanetary probes. However, the space industry is ever-evolving. With new competitors like SpaceX and Blue Origin pushing the boundaries of launch technology, the ESA recognized the need for a more advanced, cost-effective solution to maintain its competitive edge. Ariane 6 was designed with many main goals in mind: lower launch costs, greater flexibility, and a dependable platform for a wide range of missions. The development process, which began in the early 2010s, has involved cutting-edge engineering and extensive collaboration across Europe. By early 2016, various European countries had agreed to provide development funds, and contracts had been signed to commence thorough design and construction of test items. While the maiden orbital flight was originally scheduled for 2020, by May 2020 the initial launch date had been pushed back to 2021. So what makes Ariane 6 stand out? Let's take a closer look at its technicalities. The rocket is available in two configurations, Ariane 6.2 and Ariane 6.4. The main difference between these two models is the amount of solid rocket boosters. The Ariane 6.2 features 2 boosters, while the Ariane 6.4 is equipped with 4. This modular approach allows for greater flexibility in matching the rocket's capabilities to the specific requirements of each mission. The core, or the lower stage of Ariane 6, is powered by the Vulcain 2.1 engine, a liquid-fueled engine burning liquid hydrogen and liquid oxygen. This engine is an evolution of the Vulcain 2 used on Ariane 5, featuring improvements in efficiency and manufacturability. It's an improved and less expensive to produce Vulcain 2.1 engine derived from the Vulcain 2 engine from Ariane 5. With a diameter of 5.4 meters, the LLPM holds about 140 tons of propellant. 2 or 4 P120 model solid rocket boosters, referred to as equipped solid rockets or ESR in Ariane 6 nomenclature, will supply additional thrust for the first stage. A single booster can provide thrust of up to 4,650 kilonewtons and holds about 142,000 kilograms of propellant. The modified Vega C launcher's first stage is the P120 motor as well. On July 16, 2018, Kourou hosted the ESR's first full-scale test, which successfully concluded with a thrust of 4,615 kilonewtons in vacuum. The upper stage, known as the Vinci stage or Upper Liquid Propulsion Module or ULPM, is powered by the Vinci engine, which also uses liquid hydrogen and liquid oxygen. It features the same 5.4-meter diameter as the LLPM and carries about 31 tons of propellant. One of the standout features of the Vinci engine is its capability for multiple restarts, allowing for precise placement of payloads into their intended orbits. One of the primary goals of Ariane 6 is to significantly reduce launch costs. Ariane 6 was being developed under a public-private collaboration, with 400 million euros reportedly being the industry's share of the 2.815 billion euros in funding from various ESA government sources. To accomplish this, numerous new production processes have been used. For instance, the use of 3D printing for certain engine components has streamlined production processes and reduced costs. Additionally, the overall design of the rocket has been optimized for efficiency and simplicity, further contributing to cost savings. Another key aspect of Ariane 6 is its versatility. The rocket is designed to accommodate a wide range of payloads, from commercial satellites to scientific instruments and interplanetary missions. This flexibility is crucial in today's rapidly changing space landscape, where the ability to adapt to various customer needs is paramount. The rocket has also undergone rigorous testing to ensure its readiness for this critical mission. This included static fire tests of the engines, simulations of various flight scenarios, and comprehensive checks of all systems. But the Ariane 6 has received criticism before for its high per-launch cost and lack of reusability. When the ESA first approved the rocket in the early 2010s, it was envisioned as an updated version of Ariane 5, optimized for cost. At the time, private companies such as SpaceX were already lowering launch costs. However, these businesses had only accomplished a few successful flights and had not yet demonstrated that reusability was viable. European officials defended the Ariane 6 rocket, claiming that their countries require independent access to space, citing geopolitical events that cut off Europe's access to the Russian Soyuz rocket as an example. Its 2020 launch date was often pushed back due to technical difficulties as well as external events, including the COVID-19 pandemic and Russia's continuous invasion of Ukraine. The Ariane 6 will deploy 9 CubeSats into low Earth orbit. A number of non-orbital experiments will also be carried by the rocket, such as 2 re-entry capsules that will undergo a trial by fire as they make their way back through the dense atmosphere of Earth. The mission preview from ESA stated that the rocket's upper stage will return to Earth as well. However, the higher stage will burn up in the atmosphere instead of surviving the journey. These payloads represent a wide spectrum of space activities, from wildlife tracking and 3D printing in space to searching for the most energetic explosions in the universe. The primary objective of this inaugural launch is to demonstrate the capabilities of the Ariane 6 and validate its design. This mission is a crucial step in proving the reliability and performance of the new launch vehicle. This 203-foot-tall rocket is designed to ensure Europe's independent access to space, supporting a wide range of missions from scientific exploration to Earth observation and commercial ventures. Looking ahead, the successful deployment of Ariane 6 is expected to have far-reaching implications for the European space industry. The rocket is poised to play a central role in a wide range of missions, from commercial satellite launches to scientific explorations and beyond. Its versatility and cost-effectiveness are likely to attract a diverse array of customers, including private companies, government agencies, and international partners. Europe has great expectations for the new launcher, which should see 9 or 12 flights annually by 2026. The Ariane 6 will ensure our guaranteed autonomous access to space and all of the science, Earth observation, technology development, and commercial possibilities that it entails, ESA officials wrote in a preview of the debut launch. With many features brand new to Ariane 6, we'll be able to carry more and take it further, while sustainably disposing of the launcher's upper stage to prevent it from becoming space debris, they added. With about 30 scheduled launches, including flights for Amazon's Kuiper satellite internet network, Ariane 6 is well-positioned to be a major player in determining the direction of space exploration in Europe. Furthermore, Ariane 6 is part of a broader strategy by the ESA to ensure Europe's continued leadership in space. The venerable Ariane 5, which was retired last year after 117 missions over nearly 3 decades, will now be replaced by the Ariane 6, which is operated by the French corporation Arianespace on behalf of the ESA. This includes collaborations with other space agencies, investments in new technologies, and ambitious missions aimed at expanding our understanding of the universe. The launch of Ariane 6 on July 9th marks a significant milestone in the evolution of space exploration. It embodies the spirit of innovation, collaboration, and ambition that drives the European space community. As we look to the skies and anticipate this groundbreaking event, we're reminded of the incredible potential of human ingenuity and the boundless possibilities that await us in the cosmos. Thank you for joining us today. Be sure to stay tuned for future updates on the launch and more exciting updates from the world of space exploration. If you enjoyed this video, don't forget to like, subscribe, and hit that bell icon to stay updated with all our latest content. See you in the next one.